We have the last sponsor for this afternoon session. We have Bender. Bender gentleman is here. Yeah, come over here. So you have only 5 minutes to speak because people are hungry here. So more you delay. I'm not cruel. Keeping people hungry is more cruel. Okay. Over to you. Yeah.
Okay, I have to this. Okay, fine. Okay, so gentlemen, ladies and gentlemen, good afternoon, and I am the last speaker before lunch, so please bother me. So basically, Bender, we are providing the online insulation monitoring and fault location system tailor-made for every applications. But today I will discuss here only for the hospital and healthcare locations. So what is the solutions we are giving? This is again as per IEC 60364, but hospital for that part is the 710 and BIS NEC SP30. I will discuss about the 2011 publication only because 2023 is still not published. So electrical safety, everybody understand, no medical location can afford this because at least in a civilized country, nobody can tolerate this such type of thing. So when we are designing for electrical safety in a medical locations, the some basic things has to be considered, that the body functions may be taken over by the apparatus during the surgery, or patient's skin may be reduced, but insulation resistance of the human body because invasive equipments are inside the skin, and then natural reaction of the body for the electrical shock is restricted because patients are under coma or sometimes in the senseless condition. And another one very, very important thing, the heart muscle is highly sensitive for the electrical current, and even 10 microampere current can be fatal, which is not possible for a normal human being. Normal human beings can tolerate 0.5 milliampere current, everybody knows. So fire and explosion risk through the use of anesthetics and other cleaning agents are there, so this has to be considered. So basically, when in the design for the electrical safety in hospital, our main motto is the top portion of the pyramid. This is the safety of the patients and staff, property of the hospitals, as well as the device, as well as the equipments. So for that reason, the main basement should be very, very strong, which is that safe locations and installations. Bender is providing that. Then safe devices and equipment. Of course, all biomedical equipments has to be very, very as per the standard requirements. And then safe operations and high level of sanitation. Safe operation means safe level of working style has to be maintained. So this is a basic thing. 30 milliampere is for the human being can tolerate for very less time. Wherever it is for the 0.01 milliampere, means 10 microampere for a patient. When a body is open on the table, this is the current is fatal. So this is the basic difference. So you can understand normal RCD of 30 milliampere is not suitable for OT and ICU during the operation. So this is the basic world map. The green color countries are following the IEC standard, whereas the NFPA standard by the American country, America, Canada, and Australia. And some Gulf countries, they don't have their own standard. So they are either following the NFPA or IEC standard, depending upon the owner of the hospitals, who is from a sponsorship coming from which country, depending upon that. So, but India is a constituent body of IEC, so we are following here IEC standard. So this is the IEC standard. I told this is the basic requirement for this IEC standard is there are specialize or categorize the entire hospital in 3 different zones. First is the group 0, then group 1 and group 2. Group 2 is the major critical zone where the operation theater or heart catheterization room, intensive care room and premature baby room, everything is there. So in basically where the invasive equipments going inside the skin, this is the group 2 locations, and other rooms are not that much critical because there are no invasive surgical equipments are using. So this is the chart, and the other side of the chart we have given this chart of NEC for 2011 edition, where you can see the group 2 locations, all the cross has given that all the anesthetic room, operation theater, or all everywhere it has given that continuity of power supply has to be maintained. In NEC it was given as a P7 location, or sorry, this is a P5 location. There is continuity of power supply should be mentioned in case of a earth fault also. In case of earth fault, insulation fault, then also continuity of the power supply has to be maintained. So this is 2 basic difference of power supply system, where it is grounded power supply, single phase given to inside the OT. So what will happen during the operation if any equipment malfunction, the short circuit current or fault current rather so go through the patient body and doctor's body and go. In that way patient and doctor can get shock. However, in the IT system, when there is a it is not grounded system, floating power supply system inside the OT, so there will be no fault current path to go through the doctor's and patient body. It can be safe. So how to do that? You have to put a insulation isolation transformer, special type of isolation transformer that IC is saying. This is the transformer standard we know. This is the 61558 standard. It has to be followed, all the parameters of that. But this 7-710 60364 has given some special conditions. This is the transformer should be 0.5 to 10 kVA range, and the leakage current in no load condition should be less than 0.5 milliampere, and it cannot be more than 10 kilowatt rating, 10 kilowatt rating. So Bender is making that type of transformer, very special type of transformer, medical grade transformer. Then insulation monitor. There has to be a special type of insulation monitor. We know the insulation monitor we have following the IEC standard 61557-8, but for medical insulation monitor has to be followed as per the Annex C of that standard, where the threshold value of the insulation will be 50 kilo ohms and the test voltage has to be 25 volt. Sorry, just I will take another 1 or 2 minutes. So Bender is also following that type of that standard, and we are manufacturing that type of insulation monitor for healthcare system. So there is we are putting that type of insulation monitor in OT and ICU system. With that we have that fault location also, because in case any insulation fault has happened anywhere, then it is very difficult to try and error method to check which sector and which equipment is faulty. So there should be fault location system. Without tripping or shut down the system, you understand the which equipment and which branch and which circuit having the problem. That's why fault location system is must. And when is group 0 and group 1 location, where that insulation monitor and IT system is not there, in that case, instead of RCD, everybody was discussed, we are proposing and we are supplying in some hospitals residual current monitoring. Instead of tripping, continuously it will monitor the leakage currents from the as low as value of 5 milliampere, and any tripping value and alarm value you can set in this type of system. It is called 24/7 monitoring. So this is our supply. We are supplying the isolation panel for OT and ICU. Then we have that our some surgeon control panels and also some insulation monitoring system. So this is also OT lights and beds we are supplying, and I think that's it from my side. I hope I have not bothered much.
Thank you, Goswami. You know, we have a AHPI team here and also KAWO. I think
Yeah.
we will definitely forward the presentation that you made to all these
I think-
our partners, the supporting
Because
partner.
another 5 minutes was required to discuss details.
Yeah, I'm
No
sure
problem.
you are there. We have a stall there. Bender has a stall. I would request everyone to interact with them during the lunch, which is around just 30 minutes. So please spend some time with Mr. Goswami and Bender, New Age and Cape. Thank you very much for supporting.